Hi everyone, welcome to this Make a Medic tutorial. Today we're going to be discussing a couple of very commonly used terms, urea and creatinine. So first of all, we're going to talk about the physiology of creatinine. So it's a byproduct of creatine metabolism within the muscle, and it's produced at a relatively constant rate, which is dependent on the extent of your muscle mass. So someone who is more muscular and has a larger muscle mass will produce a greater amount of creatinine. So it goes into the bloodstream, and from the bloodstream we can sample it and measure the serum creatinine concentration. From the bloodstream it goes to the kidneys, and it's excreted via the kidneys in your urine. And the important property about creatinine is that it's freely filtered, which means that the concentration within the plasma is the same as the concentration within the filtrate of the kidneys. So the key principle that helps you understand creatinine is that it's produced by the muscle and excreted by the kidneys at a constant rate. So provided that your muscle mass remains fairly static, which it generally does, and that your kidney function remains adequate, the serum creatinine concentration should remain fairly stable. If there is a decrease in kidney function, however, for whatever reason, it means that there's going to be reduced creatinine excretion within the urine, and hence an increase in serum creatinine. So this is why creatinine is used as a marker of kidney function. Given that there are a few other factors that contribute to creatinine concentration aside from just kidney function, there are a number of different formulae and calculations that can be done to estimate the glomerular filtration rate based on the serum creatinine and a few other factors. So it can be taken into account alongside the age, sex and ethnicity of a patient to determine the estimated glomerular filtration rate. There is also another calculation which is referred to as creatinine clearance, which also includes the height and weight of the patient, and that's sort of used as a surrogate marker for how much muscle mass they are likely to have. So moving on to urea, it's a nitrogenous waste product that's also excreted by the kidneys, and hence an elevation in your serum urea concentration would be suggestive of some sort of renal impairment. However, there are a few caveats to interpreting urea. So first of all, urea is partially reabsorbed within the kidneys, and the rate at which it is reabsorbed increases when people are dehydrated. So when dehydrated, one of the homeostatic mechanisms that aims to increase fluid reabsorption is the action of vasopressin. And vasopressin also acts on urea transporters within the kidneys to increase urea reabsorption, and hence that is why when someone has renal impairment due to dehydration, urea tends to rise proportionally more than creatinine does. Given that urea is also a breakdown product of protein metabolism, it can also rise in an upper GI bleed because the protein components of the blood cells get digested and metabolized via the urea cycle. Similarly, if someone has a high protein diet, that can also lead to a high serum urea concentration.